Hey guys, today for our algebra class we are going to be adding and subtracting radicals, and there are a few rules that we are going to follow. So rule number one is that you can only add or subtract radicals if they are like terms, and we hear that a lot, like terms. In this scenario with radicals, they are considered like terms if they have the same, what we call a radicand, and the radicand is going to be the number that is inside of the radical. So we'll give you an example. If you had 5 radical 3 and 2 radical 3, these are considered like terms because they have the same radicand. So in this scenario, 3 would be the radicand, and now that they are like terms, all you need to do is add the numbers that are outside of the radical together. So 5 and 2 would give you 7, and you keep the radical, the radicand, the same, so it would be 7 radical 3 as your answer. Okay, let's do another example. If we have 8 radical 5 plus 3 radical 5, they are like terms, so I just need to add the numbers that are on the outside of the radical. So 8 and 3 would give me 11, and I keep the radical the same, radical 5. Example 2 is going to be 3 radical 3 plus radical 27. Now, right off the bat, 3 and 27, the radicands are not the same, so we can't just add these two terms together, but we can break down radical 27. So off to the side somewhere, you need to figure out what perfect square goes into 27, and we're hoping that the other number will be 3. So, since we want them to add together, if we break down radical 27, we should get factors of radical 9 and radical 3. 9 is a perfect square. The square root of 9 turns into 3, and we bring down the radical 3 that we can't simplify any further. So this radical 27 is going to change to 3 radical 3, and now we have like terms. So now we have 3 radical 3 plus 3 radical 3, and our final answer is going to be, add the outer numbers together, 6 radical 3. If you need to pause the video now so that you can copy the rest of this down, do so, because I'm going to go to a blank page. Okay, example 3 is going to be 3 radical 6 minus 2 radical 24. These two terms are not like terms yet. We are going to break down radical 24 off to the side. So if I have radical 24, I have to figure out what perfect square will go into 24. And I'm hoping the other number will be a 6. So let's see if that works. 24 divided by 6 is 4. 4 is a perfect square. The square root of 4 is 2. So radical 24 is the same thing as 2 radical 6. So I am going to keep the 3 radical 6 minus, now this part's different. We have a 2 here already, so that 2 needs to come down, and it is going to multiply with the 2 that gets brought out from 2 radical 6, and then we're going to simplify this. So in the next step, we have 3 radical 6 minus 2 times 2 is going to be 4 radical 6. And now that they are like terms, we can, in this scenario, we are subtracting. So 3 minus 4 is going to be a negative 1. So there are 2 ways that you can write your final answer here. You can write it as negative 1 radical 6, or you can just write negative radical 6. Same concept as, like, you wouldn't normally write a negative 1 in front of x, although you could. It's kind of up to you. Okay, number 4 is going to be 5 radical 50 minus 4 radical 32. Now, both 50 and 32 are bigger numbers, and they are going to be able to be simplified because there are definitely perfect squares that can go into 50 and 32. So, off to the side somewhere, I'm going to do it over here. We're going to break down radical 50, and we're going to break down radical 32. So, if you think about 50, you have 1 and 50, that's not going to work. But then you have 2 and 25. So 25 is a perfect square. The square root of 25 is 5. So radical 50 breaks down to 5 radical 2. Now before I just write 5 radical 2 down below, I have to remember that there was already a 5 in the beginning, and that 5 has to multiply with the 5 that I'm bringing out of the radical. So you can either do that in your head and write 25, or you can show the steps that it's 5 times 5 radical 2, which would simplify to 25 radical 2. And now we have to figure out radical 32. So radical 32, so 1 and 32, that's not going to work. 2 and 16 though should, so we have radical 16 and radical 2 are factors of radical 32. 16 is a perfect square, that gives you 4. Bring down the radical 2. Now this is just a coincidence that you have a 4 and a 4, a 5 and a 5. It doesn't always happen like this. But in this scenario, we have the 4 out in front already, so that needs to be brought down to multiply with the 4 that we are taking out of the radical. So it'd be 4 times 4, radical 2. The 4 and the 4 are going to multiply to 16, radical 2. And now we finally have like terms, and we can combine them. So we have 25 minus 16, that's going to give us 9, and then we keep the radical 2 the same, so our final answer is 9 radical 2. Okay, I can probably fit another one on this page. So I'll start with negative 3 radical 5 plus radical 6 minus 4 radical 5. Okay, so if we look at the radicands, so the numbers inside of the radical, we have a 5 that matches with another 5, and then we have the 6 all by itself. And radical 6 cannot be simplified. There is no perfect square that goes into 6 aside from 1, which won't change it. So that radical 6 has nothing to combine with. But the negative 3 radical 5 and the negative 4 radical 5 are like terms, and we can add those together. So negative 3 minus 4 is going to give you a negative 7, and then you keep the radical 5, and your final answer is going to be radical 6 minus 7 radical 5. And if you need to pause the video now to go to our next and final page, you can do so to copy down the rest of the information. Okay, number 6 is going to be 3 radical 6 plus 2 radical 54. Now, we know that 6 can't be simplified in the radical, but 54 definitely can. So if we break down 54 into factors where a perfect square can go into 54, we will have radical 9 and radical 6. Now 9 is the perfect square here. That's going to simplify to 3, and then you bring down the radical 6. So we have 3 radical 6 plus, now this 2 and this 3 are outside of the radical. They need to multiply together. So if you could do it in your head, great, and you can write 6 there, or you can write down 2 times 3 and multiply it in the next step. It's up to you. So now we have 3 radical 6 plus 6 radical 6. These are finally like terms, so we can add the numbers on the outside to give us 9, and then we have radical 6. So our final answer is 9 radical 6. So number 7 is going to be negative radical 12 plus 3 radical 3. So the 3 radical 3 is going to stay as is, and the radical 12 is going to be simplified. So if we think about 12 and all its factors, we've got 1 and 12, 2 and 6, and then we also have 3 and 4. So of those, 4 is the perfect square. The square root of 4 is going to be 2, and then you're going to bring down the radical 3. Now before you just write 2 radical 3 here, you have to remember there was a negative sign to start, so that's going to follow. So you have negative 2 radical 3 plus 3 radical 3, and now you have like terms that you can combine. So negative 2 plus 3 is going to give you 1. You can either write the 1 there and have 1 radical 3 written like that, or you can just write radical 3 and it means the same thing. So last example we're going to have for number 8 is going to be 5 radical 18 minus 3 radical 2. So 3 radical 2 is as simple as it can get, but we can definitely break down 5 radical 18. So if we list the factors of 18 off to the side until we figure out the largest perfect square that can go into 18, we should end up with 9 and 2, 9 being the perfect square, which simplifies to 3 radical 2. Because there was a 5 out in front, that 5 has to multiply with this 3, and we should end up with 15 radical 2 minus 3 radical 2. Now that the radicands, which again are the numbers inside of the radical, are the same, we can combine these like terms. So we have 15 minus 3, which should give us 12, and our final answer is 12 radical 2. And that's going to conclude our notes for today.